In this video, I wanted to talk a little bit more about doing math with binary numbers. So we talked a little bit before about adding binary numbers together. Let's do one quick reminder example of that. So let's say I have two numbers in binary. We'll say they are 1, 0, 1, 1, and 1, 1. So these are in base 2, so I'll put a little 2 there to remind us of that. And just so you know, if we want to convert these to base 10, this is the 1's place, the 2's place, 4's place, 8 place. So this is 1 plus 2 plus 8. So this is equal to 11 in base 10. So that is, 11, not 1, 1. And 1, 1 in base 2 is 1 plus 2, which is 3 in base 10. So if we're adding these numbers together, we know what to expect. I'll leave that as an exercise to the viewer. So if we add these together, in the 1's place, we have two 1's. And adding those together gives us, 1 plus 1 is 2, but in binary that's 1, 0. So we have a 0 here and we need to carry the 1 up to the next place. So now we have 1 plus 1 plus 1, which is 3, which is written as 1, 1. So we have a 1 here and we also have to carry a 1 there. 1 plus 0 in the 4's place gives us a 1. 1 plus 0 in the 8's place gives us a 1. So we're left with 1, 1, 1, 0 in base 2 as the result, and that is 8 plus 4 plus 2, which is equal to 14 in base 10. So indeed, yes, 11 plus 3 is equal to 14. It's good to know what answer to expect, I guess. So let's talk about a couple other math things we can do. In binary, it's very easy to multiply or divide numbers by 2 because that is just shifting our bits, bit shifting. So in other words, if we have a number like 7, so 1, 1, 1 in base 2, that is 7 in base 10. If we want to multiply this by 2, all we have to do is take these bits. So I'm going to put some leading zeros here. All we have to do is take these bits and shift them to the left. So if I shift these 1's to the left by 1 place, 0, 1, 1, 1, 0, that is what we just saw in the last example. This is 14. So shifting things to the left multiplies by 2. Shifting things to the right is going to divide by 2. We lose this last digit, but of course, if it's a 0, that means our number was even to begin with, so we should get a nice even division by 2. If this is a 1, that means it's an odd number, so whatever digit gets bumped off here is the remainder of our division. So let's we can do a quick example of that. So let's say we have 1, 1, 0, 1. So this is 8 plus 4 plus 1, which is 13. So dividing this by 2, shifting everything to the right, we have 1, 1, 0, and we lost this 1. So we have there's some extra 1 floating over here. So this then is 4 plus 2 plus 0, which is 6. So this is, our result is 6 in base 10 with a remainder. That's not how you spell remainder. With a remainder of 1, because that was the digit that got cut off. So anyway, we can do, math stuff like that. If we want to multiply two numbers together, and we're sticking with integers here, decimals or, floating point numbers that we store with exponentials. The math for that is more complicated, but kind of building on these ideas, at least in terms of shifting bits and adding things together. So let's say we wanted to do something simple like 5 times 6. So the careful observer will notice that 5 times 6 we can break into powers of 2 like this. So this is, remember, we're really good at multiplying by 2 or powers of 2. So 5 times 6 is equal to 5 times 4 plus 5 times 2. So we can take our number 5. So 5 is 101 in base 2. So 5 times 4 is 101. So 4 is going to give us 2 zeros there. 5 times 2 is 101 with a single 0. So this operation ends up looking like this plus this, which we can do in our head. It's just 1, 1, 1, 1, 0. So this is, so 1, 2, 4, 8, 16. So this is 16 plus 8 plus 4 plus 2, which equals 30 in base 10. And indeed, that's what we expect for 5 times 6. So that is how we can do integer multiplication. There are, there are other algorithms that you can use, but this at least paints a picture of how we can use these simple operations to build up to more complicated things. And that's kind of the whole, the whole point of this, of this exercise. Okay, so what I want to talk about in the next video is how we can actually build this operation into a circuit.